Let's take a look at this example. It's number 2 from section 6.4. Let y equals 3/5 times the quantity x minus 3 squared plus 2. And we want to find the vertex of the graph. Luckily, this is in vertex form, and so we should be able to pick out the vertex pretty easily by comparing this to y equals a times x minus x sub v squared plus y sub v. Okay, and we see that x sub v is 3 and y sub v is 2. And therefore the vertex is 3, 2. Okay, then we want to write the standard form of the equation. And so we're going to start by squaring the binomial. And x minus 3 squared is x squared minus 6x plus 9. And then bring down the plus 2. Okay, next distribute the 3/5. Okay, so we get 3/5 x squared minus 3 times 6, so 18/5 x, and then plus 3 times 9, so 27/5, and then a plus 2. And lastly, we're going to combine like terms. Okay, so the like terms in this expression are those constants at the end. Okay, so we can do a little scratch work on the side. I just want to get a common denominator, and so I would multiply the 2 by 5/5. Okay, so the denominator will be a 5. So we get 27/5 plus 2 times 5/5, and that's 27/5 plus 10/5, and altogether 37/5. Okay, so lastly, y is equal to 3/5 x squared minus 18/5 x and plus 37/5. Okay, but what we're trying to do is to write what a, b, and c are, the coefficients of these terms. And so a is 3/5, b is negative 18/5, and c is 37/5. Okay, lastly, we want to pick out which graph matches the given equation. And so remember, the vertex was at 3, 2. And you can also tell from the sign of A, the leading coefficient, since it was positive, that the graph opens upward. Okay, so graph 1, this one, it does have a vertex at 3, 2, and it does open upward. So this could be our answer. The second graph opens downward, so that's definitely not it. The next graph, its vertex is at 3, negative 2, so that's not it. And then the last graph, it does have a vertex at 3, 2, and it opens up. So there must be one other thing that we could tell, maybe to determine which one of these two graphs is our answer. And so if we go back to part B, the equation that we came up with in standard form, the y-intercept of the parabola is c, or 37/5, and that's 7.4. So let's see if we can see if one of these curves appear to pass through y equals 7.4. Okay, so this first graph could definitely work. The last graph, it does look like it would pass through a y-intercept even larger than 7.4. So I'm going to select the first graph as my answer.